All right, exponent laws. First one we're going to look at is if we're multiplying and our base is the same. Now in this example here, I have both my bases are a. So that means I can first of all do the exponent laws. Now in most cases the a is going to be a number for you, and that might make it easier, but there might be the odd time where they might give you the base as a letter representing a number. So if my bases are the same and I'm multiplying, what I do with the exponents is I must add them. So I would write down a to the power of 2 plus 3. Now, whether you show me this step or not, you don't have to, but that's what your brain has to do. So when I do that, I end up with a to the 5th. So when the bases are the same, we add our exponents. The next law is when we're dividing bases. Now, sometimes the dividing could look like this, or they could actually use the actual dividing sign and put everything in one line. Either way, when you're dividing and your bases are the same like they are here, you take the exponents and you subtract them. So in this case, it would be 3 take away 2. Again, whether you show me that line or not, doesn't matter. And I end up with a to the positive 1. Now remember, what they do sometimes in your book is we don't often put the 1 here, and you don't have to either, but it's understood that it's there whether or not you show it or not. So dividing with the same base, we're going to subtract the exponents. The next exponent law we looked at had to do if we had a power to a power. So a power to a power means I already have something already to a power, and then I take the whole thing and I put it to another power. Now if I wrote this out, that would be a squared times a squared times a squared, 3 times. Now if you really wanted to, I suppose you could do that, but that would take a fair amount of time. So we know if we do that, that we actually multiply the exponents. All right, so we end up with 2 times 3, which we end up with a to the 6th. So when we have power to a power, we multiply. The next exponent law that we took a look at was the zero exponent. And I told you that teachers like using the zero exponent. They put a huge base here and then they put it all to the 0. And the reason they do that is anything to the power of 0, other than 0 itself, always equals 1. So 0 exponent equals 1. Now the next one was one that some students find a little confusing, and that is our negative exponent. Get used to it. You're going to see them next year as well if you're taking the MAP 4C course. As well, there are other exponent laws that we're not looking at that relies on the information from this for next year. A negative exponent. Well, we don't like negative exponents, so what we do is we want to get rid of it. So when we do a negative exponent, it flips our base. It reciprocates it. So in this case, my base is a, so if I reciprocate it, it'd be 1 over a. And notice what happened to the exponent. It became positive 1. So that's how that works. Now let's take another example here. So if we want, first of all, maybe we'll put that negative exponent flips base. And it's to the positive exponent. And we're going to do another example here with some numbers, because as I said, this is the one that most students have difficulty with if you're going to have difficulty. So if I have 3 to the negative 2, my base is 3, so if I reciprocate it, that would be 1 over 3, and then it would be to the positive 2. Now we're going to actually finish this question because 3 squared, is 9. So actually 3 to the negative 2 equals 1/9. Okay, let's take a look at another one. This time I'm going to have 1/4 to the negative 2. What I do in this case is I flip the base, so it's going to be 4 over 1, or just 4, and all of that will be to the positive 2. Okay, so I can actually bring that in here actually. So 4 squared would be 8, 1 squared would be 1. So if I write that down, I end up with the number 8. One more. This time, let's take a look at 2/3 to the, and let's make it a negative 3 this time. So if I want to get rid of the negative, which I always do, I'm going to reciprocate the base, so that would be 3 over 2, and I would change it to the positive 3. Now, just like the previous example, I bring that in. So really what I have is 3 to the power of 3 over 2 to the power of 3. And you can use your calculator at this point not to change it to a decimal, keep it as a fraction. So 3 to the power of 3, that's 3 times 3 times 3, or your calculator will tell you it's 27. And 8 cubed would be 2 times 2 times 2, which would give me an 8. Okay, so that's taking a look at the negative exponent. So that is a review of our exponent laws, and what you're going to be doing for the remainder of the class is working on some worksheets as well as some work from your textbook. Remember, this is your opportunity to get help. We won't be looking at this again until we review for exams.